Hi guys, good afternoon. So in the last session we covered the IPv6. So today let's start with the network architecture. Okay. So first network architecture that we are going to cover is about three-tier architecture. Okay. So what is this three-tier architecture? This is an architecture. See, an network architecture basically means how the networks are being designed in the companies. Okay. So this is used in large organizations. Okay. So consider you are working in a very large organization where there are multiple buildings. Okay. Building one and building two. These are the two buildings. So I'll name them. This one you can consider B1. This one you can consider building two. Now, in these buildings, there will be different departments. Okay. So according to different departments, what you're going to have in different departments, you're going to have switches. Okay. So one switch, two switch. Same thing in the second building also departments will be there. You will have switches in the department. And with these switches, you will have end host connected. Your end host, they will be connected. This is clear. So we can consider these are connected like this. Okay. Now at building level, what I want to do is I want to aggregate my traffic. That means I want to centrally manage all my traffic from one place in one building. So what I'll do, I'll use one more layer of switch. Same thing I'll do in the another building also. Right? And what will happen? These switches, they will connect here and here. Same way, this switch will connect here as well as here. But I also want to centralize the entire traffic from both the buildings. From centralized one place, I want to manage and monitor all the traffic. So what I'll do, again, one more layer. So one more layer of switch will be used. Okay. And this switch will connect both the buildings. Clear? Then after I will have a router to connect to the internet. So I'll be using a router. Okay. And this router will provide me connectivity to what? My internet. Consider this is internet. Okay. So this is how I'll be connecting. Now what? If I see, if this switch goes down, what will happen? This entire building network is down. Same way, if this switch goes down, this entire building network will be down. We need redundancy. So for redundancy, what we'll do? We'll use backup switches. Okay. Here also, here also. And these backup switches, they will connect to all the switches. Connect here as well as here. Same way, this switch will also connect here as well as here. Okay. Then they will also aggregate the traffic here. Correct. And also they will connect to each other for load balancing purpose, so that one switch will not handle all the traffic. This is clear. Now you see here I got the backup, but now I have one switch. If it goes, this one goes down, everything is down, right? So what I need to do, I need to use one more switch as a backup for this. So I'll use a backup switch here. And this backup switch will connect to all these switches. Here, here, as well as here. And this will also connect for the load balancing problem. But now I have only one ISP. If my one ISP is down, again everything is down, no communication. So I need a backup for the router also, correct? So I'll use a backup router as well. Okay, so I'm considering this is my primary service provider and this is my backup. So I want that, okay, my traffic should be forwarded from the primary only. Remember HSRP, FHRP concept, that you can do it. Also, if this interface will only go down, I'm not saying router will go down. If only this interface will go down, so still my ISP problem is not there. This is just the interface or link problem. So I want that, okay, if this interface goes down, still my traffic should pass through primary ISP only. But how is that possible? Because if this is down, I don't have the connectivity to my primary ISP. So what I'll do, I'll make a connection between these two also. Okay, and I will give a route that, okay, see, by default, this will be what directly connected network. And for directly connected, AD value is 0. And I will configure one static route that for the same network, but via this path. So what will happen? The AD value will be 1. So this will become what? Floating static route. So first preference will be given to this one. And if this is not available, automatically my traffic will pass like this. So that even if this interface problem is there, my traffic will still pass through the primary ISP only. If my entire ISP is down, automatically my traffic will pass through the secondary ISP. This is clear? No? Which one? No, not for the virtual gateway. Here HSRP definitely we will configure. Okay, for the redundancy, so that we don't have to go and change the gateway here. Okay. Now, why this is called as 3-tier architecture? Because how many layers of switches I have? 1, 2, 3. This is why it is known as 3-tier architecture. Okay. So in the 3-tier architecture, what will happen? See, this is the first layer of switches. This is your first layer of switches. This layer, you call it as an access layer. This layer, you call it as a access layer. So this is the layer where you're going to configure all the security features like port security. Okay, your BPDU guard, port fast features, DHCP snooping, all those concepts you will be configuring here. That means anything related to the host, you will be configuring on these switches. Okay. Then after, we have another layer where the traffic will aggregate from access layer. So access layer is the layer where you will connect your end host. Okay. Then after, we have this layer. So this layer is known as distribution layer, because any traffic that has to go from one department to another department will go via these switches. And I can perform here VLAN configurations. I can segment my network because one department will be in one VLAN. Okay. So here I can go and configure VLANs. Okay. And any sort of inter VLAN routing, if I have to do all those things, I can configure here. Clear? Then I have the next layer of my switches. Okay. This is the third layer of the switches. This is known as core layer. This is known as what? Core layer. So your core layer switches, these are the fastest switches in your network. Why? Because you can imagine what is the amount of traffic these switches will be handling. And you avoid configuring any sort of security policies on these switches. Why? If you configure security policies on your core switches will start inspecting every single frame for that policy. And the number of frames that will be passing. Imagine you have two buildings. Okay, so you can already imagine the number of systems that will be there, the amount of traffic that will be there. So your switches will start inspecting every single packet of frame with that policy. And this will have a lot of high CPU uses. And you don't want that because this will cause latency. So you don't want any sort of latency. That's why all the security configurations, most of it, you will do it in the access layer and distribution layer. This is clear. This is your three-tier architecture. Now let's talk about two-tier architecture. Now this is three-tier used in the large organization. Two-tier, smaller organization. Like this is MNC. Now you're working in a local company, but still it is a big company. Okay. So this time you're working in a company which have only one building, not multiple, but only one building. So one building means the architecture will exactly remain the same. Okay. You will have departments. In the departments, you will have switches. With these switches, you will connect your end host. Okay. Now to aggregate the traffic, you will use a one more layer of switches. And for backup of this switch, one more switch you will use. Right. Then after you will use what? ISP. So ISP you need two only, primary and secondary. And here you don't have any other building, so you do not need one more layer of switch to aggregate the traffic. Your traffic is already aggregated here. Okay. So ISP you will use two, and then finally you have your internet. Okay. So here the connections will be as it is, what we are having here. That these are the access layer switches where end host will connect. And remember, access layer switches will not connect to each other. Why? These are departmental switches. You do not want to provide connectivity. You want to isolate. So that's why if you want to provide communication, you will be using inter-VLAN routing. This is clear. And these switches, they will connect to each other. Then you have your ISP, primary and secondary, and this is just in case your interface goes down. So you will take all the possibilities in mind. And this is your two-tier architecture. Now you already know why the name is two-tier, because only two layers. So this is your two-tier architecture. Okay. So in here, what will happen? You have two layers only. Okay. Only two layers of switches we have. And this is the first layer. And this is the second. Okay. Again, this will be known as what? Access layer, where you connect your end host, you configure the security policies for the host. And this is the layer that is combining the features of these two layers. So this layer will be known as collapse distribution. Core layer. This is how this, which is combining the features of both the layers, distribution also, core also. So that means both the functions will be done here, inter-VLAN routing and all those things will configure here. Okay. This is clear, the two-tier architecture. Now let's say you are working even small organization, startup only. Then, so if you are using a startup, in a startup, what will happen? You will use architecture, which is known as Soho. What is Soho? Small office, home office. very small organization. Okay. So in the Soho architecture, what will happen? That internet is there. From the internet, you will take an internet connection. So your ISP will give you what? One device router. Okay. Then with this router, you can have the internet connection. You want multiple devices to connect, you can use a switch. And if you need a wireless connection also, you can use a wireless access point. Okay. So this is how your Soho architecture will be. Router. Okay. If this is not looking like router, now it should be looking like a router. Okay. So here what will happen? That this is what your router is. This is your switch. And this is access point. Okay. So with this switch, if you want to connect your devices, like, you want to connect a PC, printer, server, whatever you want to connect. So what all the devices you have, those devices you will be connecting here. Okay. And this Wi-Fi access point, it will broadcast a wireless range in an area. So whatever your wireless devices are there, they will connect wirelessly here. Okay. This is your Soho architecture, like our home network. Okay. This is clear. Then another architecture that is specifically available for data centers. Okay, these architectures, they are not used in the data centers because in the data centers, we do not connect PCs. There we connect data servers. So that architecture is known as spine and leaf architecture. Let me choose. There we use spine and leaf architecture. Okay. So in the spine and leaf, only two layers will be there. One will be the spine layer, second will be the leaf layer. Okay. So your data center architecture, it is known for scalability because data is something that keeps on increasing. Okay. So you will have some switches where your data centers will be connected. These are data servers. Okay, not PCs. These are data servers. And these switches, they will be connected to one more layer of switches. Okay. And how the connection will be? See, this first layer, this is known as what? This is known as your spine layer. This is known as what? Spine layer, and this layer will be known as your leaf layer. So in spine and leaf architecture, what happens? On all the spine layer switches, they will be connected to all the leaf layer switches. Okay, same like, mesh architecture. In the mesh topology, similar kind of stuff is there. This is spine layer switch. It will connect here. It will connect here. This will connect here. This will not, sorry, this will connect here. And they will not connect to each other. Neither these will connect. And here your data servers will be connected. Now this architecture is available for higher scalability. Okay, how the scalability, let's say, now I need more data servers. So all I need to do is what? I will just go and connect one more leaf layer switch here. And with that, I can connect more data servers. Okay. And what will happen? I'll connect here data servers. And I'll provide one connection from here. That's it. I have just connected more data servers. If I feel like, okay, I need more spine layer switches. So all I need to do is I'll connect a spine layer switch and I'll connect it to all these switches. This is it. Connect here, here, and here. So you can easily scale this architecture. This is why this architecture is used in the organization and sorry, in the data servers. And also here what will happen? The latency will be very less. Why? Because see, whenever, let's say, for example, I am sharing a Google Drive access to you. So doesn't matter I'm sharing with you or not. I'm not really sharing the data. I'm just sharing the access to the data. So that means if I'm sharing something, you are also using Google Drive. I'm also using the Google Drive. It is the same data server eventually. Okay. So eventually your data will pass from one data server to another data server only. It is not coming physically to us. Okay. So here latency will be very less in this architecture. That's why this architecture is used in the data centers. Okay. This one is used in data centers. Okay. Then one more architecture is there, which is in use in current time, which we say on-premise and cloud. Cloud architecture. So what is on-premise? That means all the architecture you want to have, entire network you want to have. So it should be physically present in your organization, right? Now imagine that I want to have a startup, and when I want to buy the devices for my network design, I cannot say that, okay, after 1 month I will change, or after 5 months, 6 months I can change. No, I have to plan for 5 to 10 years, because it will be one-time implementation. Every time I cannot go and change it. So if I will think, let's say today I'm serving 1,000 customers. I have 1,000 customers to serve, but I think that, okay, my business will scale to 10 lakh customers or 1 million customers or 10 million customers in the coming 5 years. Okay, let's plan for 5 years on. So now I have to purchase the resources according to that time. So that up till 5 years, I don't have to think about any sort of investment. Okay. And if I go and plan something like this, then let's say my server machine will itself cost me 20 lakh rupees. Then I will go for licensing that. And when I go for license will cost me another 5 lakh rupees. Okay. Then after I need to purchase about routers, switches, all those things I need to purchase. Other than that, if I'm having a server in my organization, I need to make sure power is there 24/7. I need to think of power backup. I need to think of server backup. I need to purchase a firewall also for security. I need to hire a security guy to manage that firewall. I need a system admin to manage my server. So many things are there. Then I will need a technician who will take care of my day-to-day problems, right? So you can imagine how much cost it will be. Like it will cost me around 50 to 80 lakh rupees, just initial investment. And I don't have that budget. What? Will I start a business? No chance. Just looking at that amount, that, okay, I have to do this, I have to then see, I have to physically own a place also, or I have to rent it. So again, I have to pay the rent also every month. So many problems are there. So let's say somehow I took a loan and did all this. I took a 1 crore loan, started the business. First year, very well. It was scaling. Next year, downfall. From 1,000 customers, first year I scaled to 10,000 customers. But suddenly next year, due to some reason, it came down to 500. Now what? Big loss. Now I'm not even able to pay the rent. Forget about the infra or the salaries. Now what? Big loss. So that is the benefit your cloud provides you. So on-premise solutions are good if your company is good enough. Okay. If you are going to scale it, no problem. But nowadays, all the startups, they are starting with cloud architecture. Once you have set up, okay, in the cloud, you started, you're doing really well, and now you want your resources to be there in your premise. You can own and you can handle all that stuff, the admin's job and all those things you can handle. You can keep it in the premise. But still, most of the architectures, they are shifting towards cloud only. Why? First of all, you don't need to rent a place. You can work from your home. You can start your business from home. You don't need to buy a server. Physical server, you don't need to buy. Plus, the biggest benefit is today, let's say I am serving 1,000 customers. So I will pay my cloud provider according to that. If my customers are decreasing, I can say, okay, I cannot pay this, just decrease my plan. They will decrease my plan, I will pay less, right? So similar benefits are there in the cloud. That In the cloud, you pay for what you use. That's it. How much you use, that much you pay. You don't use, you don't pay. That is the benefit of cloud. Now, in cloud architectures, we have, few cloud deployment methods. We have first one is infra as a service, which is in this, what will happen? You will be given with the infra. That means you will be given with hardware, CPU, storage, all those things. You install your operating system, install your application, put in your data and start working. Second architecture, platform as a service. Which is, so what is platform as a service? This time the provider will give you with the operating system also. You just need to install application and you just need to start working. They will handle the rest of everything. Then we have software as a service, widely being used. In our day-to-day life, we are using it. What Google Drive, software as a service. We don't handle. So in software as a service, even your application is being handled by the provider only. We are not caring about how our application is functioning. We have to maintain the uptime and all. Nothing we just care about. We just put in data, we download data, we upload data. And we just pay for the use of the application. Zoom right now we are using. Zoom is what? Software as a service. For using this software, we are paying it. Okay. So all these things are what? Software as a service. Clear? So this is how the cloud architecture is. Clear? Online people? Network architectures are clear?
Yes, sir.
All right. Then let's talk about what small concept. CDP and LLDP. Okay. CDP stands for Cisco Discovery Protocol. Okay. Now, why this CDP and LLDP are used? So at layer 2, you can design the topology by using CDP and LLDP. See, looking at the rack, we cannot be sure how the devices are connected. But using CDP and LLDP, we can design the entire topology of the network. Okay. So this is Cisco Discovery Protocol. As the name suggests, this is a Cisco proprietary protocol. Okay. And for this protocol, other than this, what we can say about it? This is by default enabled. There's not much about it. Okay. This is by default enabled in the Cisco switches or the routers, or let me say Cisco devices. Okay. So how can you check the topology? So you can say show CDP neighbors to check. And if you want more detail about them, like IP address information also it can provide. So you can say show CDP neighbors. Okay. If you want to enable CDP, all the command you have to say CDP run. And if you want to disable it, no CDP. This is it. Okay. Now, same thing with the LLDPs. This is for Cisco. In other vendors, we have LLDP. Okay. Stands for Link Layer Discovery Protocol. This is an open standard protocol. And if you want to enable it, commands are exactly the same. Just instead of CDP, LLDP. That's it. Okay. Now let's go and check it. So why? How the cloud is working? How you are getting connected to the cloud? Yes, but not much. How not much? Think about it. Because when you use the own physical unit, you need both. That means like server admin kind of jobs. But you are network admins. Networks are going to be there. Okay, so physical infra will be there. Even if you are having virtual devices to manage the virtual devices, also somebody is needed. Okay, so let's take two switches, sorry, one switch and two routers. Simple topology. Or like one place, two switches I use. R1, R2. This is the kind of topology I'm having here. And 111 and 112. So let's go and set the IP address. R1, 80/0 IP address. Let's use it report only. Here STP is enabled taking 50 seconds. I'll enable port fast. Or now not needed also. Just I'm changing the host name. So you can understand where which device is connected. This is S1, this is. Now see here. Let's say these 4 devices, they are available in a rack. So in the rack, these devices are going to be available like this, one over the other. You will not understand how they are connected. So what you can do, you can just like, if I want to go to the R1 and I can go and say in the privilege show CDP neighbors. See here. So it is saying S1. Right now, 2 entries are there. Why? Because earlier the name was switch and now the name is S1. So if I fast forward, then after you will see only 1 entry. Okay. So it says one device is connected to this router, which is S1. And what is the capability of this device? S. S means switch. So that means with this router, switch is connected. Name of the switch is S1. On which interface it is connected? Gig 0/0. So I can start drawing with this information. I can start drawing that, okay, if this is my router, let me change the code. If this is my router, so on the gig 0/0 interface, what is connected? Switch is connected. Okay. And what is the switch interface? F0/1. This much I came to know. Now what I need to do, I need to go to this switch. Okay. So I'll go to the switch. To this switch. Okay. And use the same command. Show CDP neighbors. Okay. And also when I was checking the R1, I know that the name of this device is what? I forgot to mention the name. That the name of this device is R1 and this device name is S1. Now, when I check on S1, I came to know that, okay, 2 devices are connected, R1 and S2. Okay. So R1 is a router and it is connected on F0/1. Already there. S2 is there, switch it is, and on which interface? F0/2. So this is my F0/2 interface. Here, what is there? Switch is there. What is the switch interface? What is the name? S2. This way I can keep on designing the topology. I will just check on the devices and this way they will tell me about port information and all. If I want IP address information also. Okay, so what I can do here. I can say show CDP neighbor detail. Okay, so do you see? It will tell me that this is R1 device and this is the IP address of the R1 device. So even I can write down the IP addresses also. So I can completely know my topology, how it is connected. Is that clear? And about the S2, so what is the S2 device? And this is a capability is what switch. Okay, interface names, what is the IOs running on that particular switch? All these informations we can get by using the detail command. Clear? So this is how CDP works. Same thing you can enable LLDP. Right now LLDP is not enabled. So if I say show LLDP neighbors, not enabled. So you have to go and enable all these devices with LLDP if you want to have. So how do you enable it? All you need to say LLDP run, that's it. And all the devices should be running it, otherwise they will not share the information with each other. If one device is running, another device is not running, it is kind of situation, one person is speaking English, another one is not speaking. They will not communicate. LLDP run, same command in all the devices. Okay. Now what? Just go and check here. Show, first of all, CDP. Show CDP neighbors. I will show you the difference. Show LLDP neighbors. Only difference will be here. This one is what? Capability is B. B means what? Bridge. Switches, they will name it as a bridge. That's it. Remaining everything's S1, logical interface, hold time, capability, platform. Here platform information is not there, but other port ID information is there. And here this will give you IP address information. CDP will give you IP address information. LLDP will give you MAC address information. Show LLDP neighbor detail. So here it will give you the MAC address information. This is how your LLDP. Which one? Yeah, even router, it will not give the IP address, it will give you the MAC address information. CDP gives IP address, LLDP gives MAC address. This is how it is. Clear? If you want to disable, no LLDP run, no CDP run. Clear? Online people? All right.
Oh, yes, sir.
Then other than this, let's go with tomorrow we'll finish CCNA. Tomorrow last lecture. Now understand few terms related to QoS and differences between site-to-site and remote access VPN. See, related to QoS, we have to understand 6 terms. First of all, understand what is QoS. QoS is what? Quality of service. So it is basically used to prioritize one type of traffic over another type of traffic. Okay. See, in companies, there will be multiple users who will be using the network. So might be your employees are, watching YouTube. Some employees are playing online games. Some are watching online movies. Somebody is downloading some movies, right? Somebody is downloading games. So like that, they will consume your bandwidth. Now you have limited bandwidth, either 1 Gbps or whatever the bandwidth you're having, right? So if everybody will start using this kind like this, your network, then you will not have proper bandwidth for your actual traffic, right? And what will happen? Your packets will start dropping or you will have high latency. So that means these are the situations when your network will be congested. There will be congestion in your network. So during these kind of scenarios, you want that your network should be run reliably. Your network should be running reliably and smoothly. It should not drop your important traffic. Okay. So with the help of QoS, we first of all classify the traffic, and then we say this is of high priority, this is low, and this is least. So that during these kind of situation, still your high priority traffic will be forwarded without any drop. Okay. So quality of service is a set of technologies, tools, and approaches that you can apply to a network. The goal of QoS is to guarantee the network's ability to reliably run applications and traffic despite limited capacity. Okay. So some QoS tools, they will do their job by handling different packets differently. They will throttle the bandwidth in certain some circumstances, and they will change the priorities on the fly. Okay. So what do we have to understand? These are the 6 terms that we have to understand: classification, marking, polishing and shaping, congestion, and filling. So see here, the first step is what? Classification. That means you classify your traffic into different categories. That, okay, this is my data traffic, this is voice traffic, this is video traffic. Now, or else you can define according to your company requirements that this is important traffic, this is less important, this is least important. Okay. So classification is at the core of the QoS, and it is the ability for a device to identify different traffic types so you can properly prioritize one over the other. Okay. Then once you have classified your traffic into different types, now what you need to put a tag on it that this is high priority, this is low priority, and least priority. So you will mark the packets with the priorities. So your marking involves tagging a packet as it enters the router so that subsequent devices recognize the traffic without needing to spend processor time inspecting it. if one router will put, or one device will put, let's say router, so one router will put the tag on it. So other routers, they will not again check and inspect the traffic. They will just see the tag and they will forward it accordingly. Okay. They will not again spend the time to, first of all, classify it and then put the tags. No, they will just see, okay, it is a high priority. First, let's forward this one. Okay. Now, once you have defined that, okay, this is my traffic and this is the priority for this traffic. Now you want to take an action during congestion, like high priority, low, least. So some traffic is there that you care about, but even than that traffic, more important traffic is there. Okay. So there are two actions we are taking. One is the polishing and second is the shaping. What is the policy? In both of them, what you will do, you are going to set a threshold limit. Okay, you will set a threshold. For example, in the polishing, what I'll do, my connection is, let's say, 300 Mbps, or just consider 100 only for easier explanation. My bandwidth is what? 100 Mbps. So I will say that, okay, my non-important traffic should not exceed 20 Mbps. Now I have set a threshold limit. Okay. So now what? If the non-important traffic, it will try to exceed this limit. Whatever the traffic is there, instantly cut off, drop the traffic. No forwarding. This is the traffic that will be immediately dropped. So in polishing, what will happen? Quality of service polishing allows you to set an upper limit. And when the traffic will hit that amount, the tool will cut the traffic and doesn't allow anymore. But this way, if there is some traffic that is important for your company, but not very important. Okay, so what you want to do, whatever the traffic you care about, for that, you will apply shaping, and the traffic that you don't care about, you will apply polishing. So in shaping also, you will set the upper limit. Again, 100 Mbps is there. Again, you said non-important traffic, 20 Mbps is the limit. If the traffic tries to go beyond this limit, this extra traffic will be stored in the buffer. And whenever there is a lower bandwidth use, there it will accommodate it. That means it will send it, but with a delay. There will be delay, but your traffic will not be dropped. Your router will try to forward it at a later point of time. This is how your shaping works. Okay. So shaping is a little bit like polishing only, but it's a kinder of gentler version. So shaping is for the traffic that we care about. So polishing might kill the packets to save the bandwidth. Shaping tools will hold the access data in the memory and try to transmit it at a later time. But how your QoS will come to know that somebody is trying to use more bandwidth and all? For that reason, we have congestion avoidance tools. They will look out for the congestion scenarios. So congestion avoidance tools, they will shut down the possibility of congestion by watching for certain limits on a router and then taking the action, either polishing or shaping what you have configured. As a router's traffic builds up, congestion avoidance tools, they will look for the devices that are at the highest risk of consuming the entire bandwidth amount. They will keep on checking it. And when the bandwidth hits a specific amount, take the action, either polishing or shaping, whatever you have configured. Then we have queuing. What is queuing? That means when the router is getting an interface, when router is getting traffic on an interface, it can come, your high priority traffic, low priority traffic, any traffic can come first. But what router will do? Router will stop the traffic there. It will shuffle the traffic and put the high priority first, low priority, least priority. Arrange the data in the priority order. So with queuing tools, you can instruct the router to shuffle the packets around to put the most important traffic first. Is that clear? These are the terms of your quality of service. Now here you have to study these terms. In your NP, you will be performing QoS. You will be changing the priorities. Okay. This is clear. Any doubt in these 6 terms? Router. You will configure the QoS on the routers. Okay. Then let's talk about a VPN. What is a VPN? Other than full form, tell me something. Why do you use VPN or do you not use VPN? Change the IP address. Why you want to change the IP address? See, look according to the company perspective. Companies, they are having communication. I might have a company that is having one of the branch in Bangalore and another branch in Delhi. So now if I want two branches to communicate, first of all, I want that my communication should not be snipped by anyone else. So if I want to go with this kind of scenario, what I have to do, I have to have my own dedicated line from Bangalore to Delhi. Imagine having a cable for internet or connectivity between Bangalore and Delhi approx 2500 kilometers. Possible? Even if you try, so you will have to hire a company for that. You will have to hire labor for that. Then how much time they will take to lay the cable from Bangalore to Delhi? Okay. Then in India, we know every day roads are digging. You just lay the cable in Bangalore, go out, and somewhere somebody here was digging the road and cable is got damaged. So that means maintenance of the cable is very disaster. So having a cable is first of all that big cable very expensive. 2500 kilometers of cable, highly expensive. Not a like if I try to have a startup and two branches, I might have to sell my company to just buy the cable, right? So not possible for a company. Then other than that, other solution what I have, I need a cable. I need a dedicated cable. So another option I have is I can ask my service provider because they already have the cables in the entire country. So I can ask them that, okay, give me one dedicated cable, and in that cable, there should be nobody's traffic. Now, this is a kind of situation you want to go from Bangalore to Delhi, and you are telling the airport authority or the airline company that, okay, there should be nobody else in the plane. How costly it will be? If you try to hire a plane from Bangalore to Delhi, how costly it will be? Same like that. So that concept in the networking, we call it lease line. That you take a dedicated line from your ISP. In that line, there will be nobody else's traffic, but that is very expensive. Okay, again, you cannot go with the solution because every month you have to pay a lot. Then another option, you might say, okay, I'll go with other people, cheaper option, right? You have to share. So if you start sharing that concept in the networking, we call it as the MPLS. You will have a line, but that line will be shared with other people also. Although your traffic will be segregated in the airplane, your seat will be reserved. But same at the same time with you, other people will also go. That means in the same line at the same time, other people's traffic will also go, but your traffic is segregated. Nobody will disturb your traffic. But again, you don't want to take a risk. Again, you don't want to take a risk. So if you don't want to go with that, then we have last option left. That is internet. I will use internet, right? I'll just take an internet connection from my service provider, and then I'll use an internet connection. So if I'm using internet connection, my other branch is also connected to the internet. So my traffic is going over the internet, and the internet is the most insecure network. And if I want to secure my traffic there, I can use a VPN. Okay. Even in the MPLS or in the lease line also, I can go and use a VPN, no doubt. But if I don't want to pay, I can use a VPN then. Okay. So they will use a VPN. Now, with the help of VPN, what will happen? That a secure tunnel will be created between the two branches. Okay, and your traffic will pass through the tunnel. So first of all, your tunnel is encrypted. Then second thing, the traffic inside the tunnel is encrypted. So that means nobody will be able to see your traffic and you can securely communicate. So the main reason behind VPN is what? That the main reason behind VPN is to have secure communication over the insecure network. Okay. This is clear why VPN is used. Okay. Now, according to organization perspective, you have two types of VPN, site to site and remote access. These are the two types of VPN you have. So in the site to site VPN, definitely two branches will be there between which the VPN tunnel will be created. Consider this is your Bangalore branch. This is your Delhi branch. So here the VPN tunnel will be created and VPN configuration will be there on the edge router. Okay. Only the edge routers are going to have a VPN configuration. You don't need VPN configuration on the company systems. Clear? Okay. So here what will happen? The source IP. Yes, Chami, any doubts? Here what will happen? The source IP and the destination IP, both will be fixed. You will have one public IP here. This guy, this branch will have one public IP here. Between these two public IPs, communication will be there, and a tunnel will be set up. Okay, so these IPs will be fixed. Clear? Okay. Another type of VPN you have is what? Remote access VPN. Remote access VPN is a VPN configuration that is used for employees who are working remotely. So let's say I am working from home. So if I'm working from home, I will use my home internet connection to connect to my company. So what will happen? My traffic will pass through the internet again. I want to secure this. So what my company will do, they will have a VPN server here, and I will have a VPN configuration here in my laptop. I'll connect to the VPN. As soon as I'll connect to the VPN, a tunnel will be set up between my system and my organization VPN server. Okay. And what will happen? I will directly get connected to my organization private network. So now this will be a kind of situation as if I'm already there in the organization and working from there. This is how your work from home scenario works. Okay. So in remote access VPN, what will happen? The source IP. See, who will initiate the tunnel setup? The person who is working remotely, because he will try to connect to the VPN. Okay. So here this guy will initiate. So this is the source and this is the destination. So here destination IP is fixed, source IP is not fixed. Maybe I'm working from my home. Maybe I'm working from my friend's home. Maybe I'm working from airport or railway station or bus station. Everywhere I will have a different IP, depending on which network I'm connecting to. So this IP is not fixed and this IP is fixed. In case of site-to-site VPN, all the employees in the organization, everybody doesn't need a VPN configuration. But here, every person who is working remotely will need a VPN setup, and they will initiate a tunnel setup. Here, tunnel setup will be initiated by the edge routers only. This is clear? Okay, now let's see the differences. Differences between your site-to-site and remote access VPN. So if you talk about the differences, so your site-to-site will create an encrypted tunnel from one customer network to remote site. Okay. While here, what will happen? Individual users are connected to the private network in the remote access. Here, what will happen? The VPN does not need setup on the each client. In company systems do not need the setup. Only edge router will need. Here, it will require. Okay, everybody who is working remotely, they will require a VPN setup. Who will initiate? So here site-to-site VPN does not require every user to initiate the tunnel setup. Why? It will be initiated by the edge device. And here it will require every remote access user to initiate the VPN tunnel setup. Clear? Here it supports IPsec technology. That means this is a protocol suite that is used to provide security to your VPN tunnels. Here both things are used, SSL also, IPsec also. Okay, if you are using web-based VPN, SSL. If you are using any other type of VPN, then it will use IPsec. Here, multiple users are not allowed. Why? Because only edge devices are initiating the setup. So multiple users will not be initiating. And here, everybody will be initiating who is working remotely. So here, multiple users are allowed. This is clear. So eventually, what your VPN does is that it encrypts your traffic. Okay, it encrypts your traffic. So that means we have to know about types of encryption also. So we have two types of encryption. One is symmetric and second is asymmetric. This is symmetric encryption. Okay, one is symmetric, another one is asymmetric, which is also known as public key. In symmetric encryption, what happens? There is only one key for encryption as well as decryption. If you want to encrypt the data or decrypt the data, there is only one key. Kind of, you can say like the lock in your home. Same key you use it for locking the door. Same key you use for unlocking the door. So here we use a key. Okay, let's say, and key can be anything. Like let's say, for example, I can say Cisco, kind of a password. Password to lock the data, password to unlock the data. Okay, so this is the same thing. So this is where the key for encryption and decryption is the same. And both communicating parties, they must possess the same key. But with symmetric encryption, what is the problem? That if somehow this key got leaked, so anybody who has this key can decrypt the information. That's why we have asymmetric encryption. In asymmetric encryption, a pair of keys will be generated. So there will be two keys, public key and private key. Public key will be used for encryption. Private key will be used for decryption. Here, if you have encrypted something using the public key, you cannot decrypt again it with the public key only. Same key cannot be used for encryption as well as decryption. Something you have encrypted using public key, that can only be decrypted with the correct private key. Okay. So whenever you generate public and private keys are not shared with anyone. Here you have to share the same key, right? So there are chances that it might go to some wrong person. But here, private key is not shared with anyone. Only public key is shared. So that means if I'm sending some data, nobody will know it. And if somebody is encrypting the data using my public key and they are sending it to me, so I have the correct private key. Nobody else can decrypt it. This is how your asymmetric encryption is. So here two keys will be there, public and private. Public key will be used for encryption. Private key will be used for decryption. This is clear. Then RSA algorithm. Remember SSH? Crypto key generate RSA. So that RSA is what? This encryption algorithm. And RSA is a asymmetrical encryption algorithm. Very secure. Okay. So this is typically done through the RSA, which stands for Reverse Samir and Adelman. These are the names of the people who developed this algorithm, which has essentially been the foundation of internet security for around 2 decades. So of course, not two, more than two it is. Okay. For a very long time, they have been securing. RSA has been used and still today it is being used. Okay. This is clear. And for maintaining the integrity, to know whether you are connecting to the correct VPN server or not, checksums, okay, integrity checks are used. And for that, hashing is used. So for hashing, one of the algorithm that can be used is SHA, secure hashing algorithm. So in this process, what will happen? A unique fingerprint, kind of checksum, is created to validate the TLS certificate. Okay, to check whether you are connecting to the correct servers or you are connecting to the server you're supposed to be. If there is no integrity check, a hacker could read out your traffic to their own VPN server instead of your VPN provider. So hackers can do that. Okay, so for that, hashing is also used in the VPN. Okay. Now there are certain VPN protocols that you will be studying in your NP about SSL VPN, TLS VPN. Okay, so see, when you will go to your NP, so in your NP for few days you will study. Okay, around I think 3 to 4 days or max to max a week. But when you go to CCI security, you will study VPNs for 6 weeks. That big of a module it is. You will study around 10 to 12 different types of VPN configurations. Okay. So eventually, step by step, they will be coming. Right now, you are studying introduction, theoretical part. In the NP, you will study it for configurational part, but few days. And if you come to the IE, then you study for 6 to 8 weeks approx. Okay, just VPN. So you'll study about these protocols like IQ version 2, L2TP, SSTP, WireGuard, TPTP. All these things you're going to study there. Clear? Okay. So this was your introduction. Main reason behind this, you must understand the difference between site to site and remote access VPN. Okay, which is this part. Any doubt in this one? More about it, automatically you will understand when you will start configuring these things. Okay. Okay, so this is also done. Then let's cover one topic which is not there in the syllabus, but important. We have done backup and restore, right? Password recovery we have. Okay. The password record. This is very important. This for organization perspective. Because small mistake, you end up losing all your configurations. Important, sensitive, critical. Okay. Like stepwise, it is barely 2-3 steps. Okay. See here. Let's say this router itself right now. Okay. This router is there. And I'll go and configure a password here. 1, 2, 3. Okay. Now, let me write the configuration. I have written the configuration. If I say enable, asking password and I don't know the password. If I don't know the password, I cannot get to the privilege mode. I cannot remove or change the password or do the configurations. Even if I go and restart this, okay, I'll go and restart the router. So still it is there in my NVRAM. So it will load in the RAM and it will again ask me for password. Okay. Yes, enable, again asking me for password. So in this scenario, what you have to do, you just have to go and restart your device, power it off, power it on. When your iOS is loading, you have to press Control and break. From the keyboard, Control and break you have to press. And here you have to give a command, config 2142. That means you are configuring a register 2142. So what is this 2142 register? It says that bypass the NVRAM. If your NVRAM will be bypassed, your router will not load the configuration from NVRAM to RAM, and your router will not have the password. Just this and then reset. So let me copy these two commands. Not removing the password, we are just bypassing. Your configuration will still be there. Just router will not load in the RAM. So that means router will start like a fresh router without configuration. Okay. So here the steps are: number 1, start the router while the router iOS is loading. Press Control plus. Okay. You will go to the Roman mode. Okay, once you go to the Roman mode, these are the commands you have to say in the Roman mode. Okay. Now what? Your router will restart. You see, it is asking system configuration dialog. That means it is considering no configuration in the environment. Then after enable, and if you check here, startup configuration is still there. Show start configuration. Your startup configuration is there. Your password is also there. Just your router is not loading it. Okay. So here, what you'll have to do, enable, and see right now directly if I change the password and write the configuration, what will do? It will just take the password and wipe out entire configuration. See, whenever you write the configuration, old configuration is replaced, new configuration is done. So when you will change the password right now your host name of the router is what? Router only, not R1. There is no IP address on this router right now. Why? Because it is not loaded the configuration. So right now it is working like a fresh router. So if you will say enable password and new password you will give. So only that new password command will be there. And old configuration when you write, it will be removed. So you don't want that because in company routers, there can be hundreds of lines of configuration or thousands of lines of configuration. And if you do such kind of thing, company will lose all entire configuration, all the VPN connections and everything. And next day, right? So you don't want that kind of scenarios. First thing we have to do is we have to save the configuration. We have to change the password, but we have to save the configuration. We do not want to lose the configuration. So where is my configuration available right now? In the startup configuration, NVRAM. I will bring that configuration in the RAM because right now I'm already in the privilege mode. So now if I will bring the configuration, I don't have any problem. So when I will bring my configuration from NVRAM to RAM, and after that I will change the password or remove the password. So I will already have all the configuration with me, and only password will be changed. So what I'll do, copy from where I want to copy, startup config to running config, enter. Do you see automatically my hostname changed to R1, and still I'm in the privilege mode. I didn't have to type the password. I'm in the privilege mode. Okay. Now what? I'll go to the global configuration mode. Enable password command was there. I'll say no enable password to remove the password. Done. Now my password is removed. I can write this configuration. Sorry, do write. Now configuration is saved. But again, if I will restart, still my configuration register is 2142. Again, it will bypass. Again, it will bypass. So what I'll do, I'll set the correct register this time. That this time load the configuration from the environment. So the correct register is how you'll set. You will say configure register and 2102. This is the correct register. Mistake. Config. Sorry, it is config register. Okay. And now just reload the router. Before that, let me copy these comments. Okay, restart. And then after, you have to use the following commands. This is not required. Okay. After this, we went to the global configuration mode and we set no enable password. Okay. And then you said do write. Okay. And then we said config 2102. Okay. And after that, you can reload the router if you want to check whether the password has been changed or not. This is the important step here. That you have to bring your startup configuration first to the running configuration. Okay. If you do not do this step, if you miss this step and you directly go for these steps, big problem. Okay. So now you can see I will have my router. Operating system is loading. So my host name will be R1, my IP address will be there, everything is going to be there, but I will not have password. Clear? Okay. So IP interface B, and whatever the IP address we configured earlier, 10.1.1.1, it is saved. Clear? This is how your password recovery will be. Clear? So only one thing you have to be careful here, which is bringing your startup back to running first. If you do not do this, then you are responsible for what is going to happen. Clear? Online people, not DP reload. You don't have to reload your DP. You have to reload the router configuration. So this is your router password recovery. Now we are left with two topics. Wireless, where we will have some configurational part. Second is automation part. This part we will cover more. Any doubts? I didn't cover wireless today because wireless will help you understand automation better. You can easily relate. That's why. So all the remaining topics I have discussed today, tomorrow we'll be discussing these two. Online people, any doubts?
Sir, SNMP, we have versions for that, right?
Version 1, version 2, version 3.
Just I'm going for that with the interview questions, top 10 interview questions. That they are asking.
Mostly right now version 2C or version 3 is used.
Version 3, like, for encryption, it's version
Higher encryption, correct. Okay. Don't worry, you'll be studying these protocols. So, online people, any doubt? No? Okay, then I'll see you guys tomorrow. All right, guys, have a good day. Bye bye.
Sure, sir.